Today we're going to take a look at solving exponential equations and being able to find the value that makes these two exponentials the same. So the steps I've given you in your notes here. The first thing we're going to do is any simplifying that we have to do using the properties of exponents. We would do that first on each side of the equation, and then we're going to rewrite the equations to make sure that they're the same base, so that the only thing that really is that has to be the same is that the exponents. Then we can just set those equal to each other and solve for that. So we're going to do a few examples and then take a look at how these properties will work. So in the first example, you'll notice that these two powers are already, they already have the same base. So we don't have to, the only thing, in order for these two to be equal, the exponents are going to have to be equal. So in other words, we just have to write that the fact is that x plus 1, that exponent, has to equal 9. Well, you can probably see straightforward that that x has to equal 8. So that is the idea, is as long as the bases are the same, then we just have to worry about the exponents, and so we can just actually set up a separate problem for the exponents. So in the second problem, you can see that the 5's are already the same base, so then we have just a linear equation that's going to be 4x plus 5 is equal to n minus 7. And you can see that we're going to just go ahead and solve that the way we would solve any other linear equation, and we end up with n is equal to 4. So when we look at the third example here, notice that there's a little work to do at the beginning. Notice that there's 2 powers of 3 being multiplied. Now, since they're the same base, we're just going to add their exponents. So on the left-hand side, we're going to end up with 3 to the power of 2k plus 2. And on the right side, we're just going to rewrite this as 5k minus 1. So at this point, you can see that we've got the same bases. So we're just going to then go ahead and just consider the exponents, because those are going to be the parts that have to be the same. So you can see we're just going to isolate the variables on the same side, and then we'll end up with having k has to equal 1 in order for us to for that to be true. And if you want to, what you can do is just check by plugging 1 in. And if you plug 1 in, notice that you'll get 3 to the 4th on the left side. And if you plug in 1 on the right side, 5 minus 1 is 4, so we end up with 2 powers. They end up being equal for that. It's good to check just to make sure that actually you can see if you get it right. On the fourth example, we have to do a little bit of work on both sides. Notice that they're both bases of 10, so that's okay. So we're just going to add exponents here. And if we add exponents, then notice that we can just set 5 equal to 3v minus 7, and then we can go ahead and solve for v. And again, if we check and see if v is equal to 4, that's going to give us 10 to the 5th power on both the left side and the right side, and those two are equal. So we've got a match here. The other types of problems that we might see is equations without a common base. Here we're just going to have to create a common base, so we're going to have to think of powers. So in this case, notice in the fifth example, 6 and 36 are not common bases. However, you might recognize 36 as a perfect square. So what we're going to do is we're going to rewrite this as, instead of writing 36, we're going to write it as 6 squared. So here's the way that we can then take any bases that might not be common and we can make them common. So that's kind of the second step then, is if we make the bases common, then all we have to do is then just go ahead and take the exponents, set them equal to each other, and notice that in this case, x has to equal 6. And again, if we just check quickly and look at this, if we take 6 to the 12th minus 10, that's equal to 36, and so that answer is correct, right? It checks out. Again, in the next example, you might see that again 8 and 2 do not match, but 8 is actually a power of 2. So you could rewrite this and write it as 2 to the 3rd power. So we've got 2 to the p minus 7. So really the two exponents p minus 7 and 3, you can really just set those equal to each other. And so then clearly that's going to have to be equal to 10 in order for a number minus 7 equals 3. And if you just check the answer here, 2 to the 10 minus 7 is 2 to the 3rd, which is 8. So again, that is a great way to check your answer. Now in the next example, in number 7 that I'll show you, one of the things that might not look familiar, but this 1 over 7 is actually a power of 7, but it's really a negative exponent. So it might be a good idea to think anytime you see a fraction, you might think negative exponents. And so what we can really do is just say that this is 7 to the negative 1 power. That's the same as 1/7, and then again we have matching powers of 7, so then we can just set the exponents equal to each other, and then usually after that it's really just a linear equation we have to solve to find that. And if we do that, notice that if we plug in the value -3 back into the equation, we get 7 to the -1, which actually is equal to 1/7. Okay, so again, that's a good way to check your answer for that. So a couple more with common bases. If we look at example number 12, notice here we've got 16 and 8, and these are not common bases, and actually we have to think of changing both of these in order to do that. And so since 16 and 8, you might think of both of those as powers of 2. So here's what we need to do. We'll write this as a power of 2. Now this is going to be 16 is 2 to the 4th. And that exponent actually gets multiplied by anything that's already in the exponent. And if we think of 8, that's 2 to the 3rd, and so again that's multiplied by anything in here. So the one thing you want to pay attention to is you're going to have to multiply out or distribute the 3 in the second part here. And so we end up with 12x, 2 to the 12x power, and then we can actually just set the 2 equal to each other. And again, notice here we're going to get a value that's a fraction, 2/3. But again, if you check your answer, it ends up being the same thing, and you don't have to necessarily work this all out. Just type it in your calculator. 16 squared on one side, and then 8 to the 2/3 power. You could put that in parentheses perhaps, and find that. Here we have not only 81, but you have 1/3. So kind of look at the bases and think, okay, 81, that's a power of 3, and then obviously 1/3 is you could use a negative exponent to express that. And so if we do that again, we take 3 to the 4th power, you're going to have to take that 4 and distribute, and then also you're going to end up taking a -1 and multiplying it by the 2x. And so then, since they have the same base, this is really just then a linear equation with the 2, and so we end up with a value of x equals 2. And again, just checking the answer, you can see that that's going to be 81 to the first power is actually gives you, when you have a -4, you flip it over, and then it's 3 to the 4th, which is 81. And I want to just show you a couple more where you may have to do a little bit more operations with it, combining and things like that. But again, if you want to see other examples, I included some of the completed notes in the folder for today. If we look at, for instance, number 17, notice that the first thing we're going to have to do is take that 64, write it as a power of 4 to match the other ones, and then we'll combine, since this is 4 to the first, really don't forget that's a to the first power. So then we just need to add those two on the right side. Now remember that when you add 4x plus 1, those are not like terms, so just keep them as separate, and you can see that what we'll end up with is x is 1/2 for that. Okay, and again, checking your answer, you can see if that works. And in this case, we're going to see that yes, it's going to give us 4 to the 4th power, I'm sorry, 4 to the 3rd power when you plug it in both. So the last one I'll do is number 18, and that is, again, notice that you've got 9. Now you could break 9 down to a power of 3, but 81 is also a power of 9. So you don't have to always go down to perhaps the prime number. If it's a multiple, obviously 81 is going to be 9 to the -2, and then we end up having to just then combine the two x's to give us 4x plus 4 is equal to -2, and then again solving it, and then obviously simplifying, we end up with -3/2, which then works in the equation. So the practice today, you'll have to do some solving, use some scratch paper, and you'll be able to check all of your answers as always in solving equations.